Good morning for all listeners, and today I'd like to say some maybe new information concerning Flint Implements collected at the region of Qasr el Sagha. This is a place near Lake Fayoum, El Fayoum. This is in Egypt. This is valley of the Nile, and there in the area of Qasr el Sagha were collected Flint implements representing Fayoumian A, B, and pre- and proto-dynastic time. So the age of this implement is between 6 and 4.5 thousand years BP. So geologically it's depression filled up with young quaternary sediments, eolian sands, and there is the small mountains and area where are where we collected implements for this presentation. There are tertiary clay stones and sandstones. It's a very impressive area. There is general view of this area. There are traces. We may look carefully and see surface of the Carunian Fayoumian lake, and there is a region area of Qasr el Sagha. There is Temple of Middle Kingdom, and between this lake, present now in depression 76 meters below sea level, and this place the lake oscillated, was bigger and smaller because there are no outflow of this lake, and depending on the climate on the rains, the lake was enlarged and was reduced, and of course together with the line of the shore of the lake migrated peoples. When lake was small, they migrated to the center of the direction of the center of the lake, and when and was bigger due to rains, they migrated to this direction. And Fayoumian A and Fayoumian B, as well as pre- and proto-dynastic sites, are localized there. Implements were collected from the surface. There is map done by our expedition in 80s of 20th century. We work a lot at this area, and material was collected more or less. These flint implements were collected at this area. There is a lot of small canyons, wadis, and these places are marked with line. There are places of occupation. On the surface, we may find implements, flint implements. There is natural photo of place where flints were napped and left probably many thousand years ago. They are still at the place, and there are examples of my collection of implements devoted for the examination, there are various blades. There is blade of skill, for example. Some Flint implements are damaged, and there are arrows, heads, and there are axes, many various implements. I am not specialist of implements, so I was informed by my friends, prehistorians, what is what. And investigation was focused on the retouch edges of these implements. These retouch edges were analyzed using various methods, using binocular microscopy, using polarizing light microscopy, mineralogical, and scanning light scanning microscopy, electron scanning microscopy. So this surface, working edges of these implements were specially analyzed, and I show you results of this examination. Generally, all implements, and especially edges of these implements, were examined from point of view of preparation of implements, as well as from point of view of work, traces of work. And for binocular microscopy were devoted, all implements were examined, but for mineralogical microscopy were selected samples where this retouch was very well seen. So let's go. We will start on observation of working edges. This is a very damaged edge of the Flint implement. The traces of work are slightly eroded, but when we look carefully, this drawing shows the general sequence of preparation of the retouch. And as we see, there are traces of work using this implement blade. So more or less, generally, these all traces of retouch are of the same size. So when we show these traces of retouch as arrows representing the force of napping, impact force, we have more or less arrows of the same size, because of course is a relation between size of traces of work and the force of napping. If napping was stronger, these traces are bigger. When force of napping was smaller, the traces are smaller. And there are calculated size of these traces of work. As you see, parameters, length of these traces of work were of various size, 2 millimeters up to 2.5 millimeters, and width of these traces are between 2 and 5 millimeters up to 6 millimeters. Low relation low to width of the traces is shown there is 0.8. And when we look to next implement, this is sickle blade, we have traces of work of various size. So for preparation of this edge, working edge, we use various force of men who prepared this implement. At the beginning was bigger, later slightly smaller, of the same size, and later smaller. So we see there oscillation of the force of napping. So this is a document of variation of force of napping of men who prepared this implement. There are diagrams and tables informing about size of these traces, how big they are. And next we have a blade slightly eroded, and we have traces of work, of retouche, and we see arrows proportional to these red arrows proportional to the size of traces, length of traces. So bigger, smaller, bigger, smaller, big, big. So it's seen well that during preparation of retouche, these men preparing implement beat this, napped this edge with various force. It was not still the same. And we have next example, edge, working edge, slightly eroded, and arrows showing the force of napping and parameters. And next, implement big, very big traces of work, of retouche traces, and size, and arrow shows the energy or the force of napping. It oscillated, was bigger and smaller, and it is document present in the edge of the flint. And next, very special kind of flint with iron oxides, this red, brownish, etc. So there is trace of preparation of edge, and next small traces of the work of this implement. And next, it's evidently seen small impact, big impact, smaller impact. So it's possible reconstruction of the force of the work of the man 1,000 years ago. And there are traces of work of this edge. We specially devoted works, our investigation, for observation of this working edge. Because of these traces, we prepare special samples for mineralogical microscopy, because together with these big traces of work, of retouche, in flint, in the edge of this implement, there are fissures in flint. I show you these fissures that are very interesting. secondary results of napping present in flint, not on the surface, not on the edge of implements, but inside. Next we have implement, it's number 8, implement number 8, other type of flint, and we see according to the size of the work of retouch, changed force of napping, smaller, slightly bigger, bigger and bigger and smaller. So this means that during preparation of the edge of this implement, the force of napping was changed from smaller to bigger, and next again smaller was. Of course, we may do reconstruction of work of preparation of this implement along all edge of this implement. It is only fragment, small reconstruction to show the way of thinking, way of reconstruction of physical parameters of napping according to the size of napping. And next we have the very big traces of napping and size of napping, and proportionally to the size of napping, the force of work, force of impact force of working men. So smaller, big and smaller, and there we have traces of work of this implement shown on the drawing like small this oscillating line. There is the scale, there are millimeters. And next implement number 10, we may say that this edge was prepared continuously with the same force of work, starting from this size of retouch edge was more or less, size was the same, so the force used for napping was more or less the same. There are parameters of traces of preparation of the retouch, and now the flint implement number 11, flint number 11. We may look to this collection what it was. This was probably the blade, and evidently were smaller traces of napping and big. So the force used for preparation of this edge was smaller, red arrow, bigger, this, smaller and bigger. So we see oscillation in preparation. During the preparation of this edge was oscillation of the force of napping, force used by men for preparation of this implement. There are traces of work, of small traces of work of this edge. And last one, evident is this edge of implement with retouch. This is the retouch and traces of work. This is axe for cutting of the wood was probably, and according to the size of traces of retouch, we have bigger force, smaller, bigger, sorry, and it's oscillating, big, smaller, and it's going to the bigger, so the force for napping was elevated. Small, higher, bigger. So this was about macroscopic observation of edge of implements from Egypt, Flint implements from Egypt. And now look more closer to the internal structure of edge, of working edge prepared using retouch. When we look on the edge of working implement, this is sample number 2. What this was, we will look. Cutting edge of the cycle. So this is magnification. We may see that this is the working edge, but under this working edge, in the structure of flint, one can see cracks. And there are cracks on the surface, near of the surface, like there, and there are cracks seen deeper. There are various imagination, because it's 100 micrometers scale and is 10 micrometers. So 0.01 millimeter, very small. But next we have arrowhead, sample number 7, and this is place where arrowhead was connected with wood. This top of the wood where was fixed this arrowhead, using traces of kind of organic material, this brownish, grayish things. But if we look more closer, using mineralogical microscopy, to the internal structure of flint, just under the working edge, this edge which was prepared using retouch, we see many generations of cracks, fissures, very small. It's 10 micrometer, so these fissures are smaller than 1 micrometer sometimes. And next, at other place of working edge of this arrowhead, we have this working edge prepared using knapping, and in the structure of flint we have many generations of various fissures, and at these fissures one can see small organic substances. We will look to these substances more closer using scanning microscopy. Next arrowhead, sample number 8. This is a peak of this arrowhead, enlarged of course, and one can see many cracks of various size under the top peak of this head, arrowhead. Various types of destruction. This is destruction on the surface of arrowhead, and this is destruction below the surface, below the working edge of this head. And this 100 times, it's 100 micrometers scale, and when it's other place 100 micrometer scale, but when we enlarge this place, for example, this is the same but enlarged 10 micrometers, one can see a lot of cracks with traces of some substances inside, in cracks, in fissures. And this is again working edge, and under the working edge of this implement, at this inside of these cracks there are traces of organic matter, and working edge of axe devoted for cutting the wood, sample number 12. And this is working edge of axe. It see that the surface is damaged, but there are cracks just under the so-called working surface. Second generation of cracks formed because of preparation of edge and because of working of axe. And there are various imagination, 100 times, 10 times at these small fissures, small cracks, one can see some organic matter. Mineralogical microscopy is not enough good for observation, for examination of these organic traces present at fissures, at cracks, sorry. And because of this, we use for next step of investigation scanning electron microscopy, and we focused our observation on substances present at cracks just after retouch edge, just after working edge of implements. And first, sample number 2, it was necessary to make selection of this type of examination. We do a lot of examination and analysis, but for presentation it's enough to see some examples useful for determination of method and determination of substances present at this secondary fissures just under surface of working edge. And there is a scanning photograph of secondary fissure just under working edge of this cycle. I don't know how to pronounce this. Cycle blade. Edge of this is somewhere there, and we enlarge this fissure, and there is this crack enlarged 25,000 times, and on the edges of this feature one can see this gray substance. There is organic substance. We have carbon about 31%. The analyses were done, chemical analyses were done using scanning electron microscopy with special apparatus for chemical analysis performed using EDS method, electron dispersive spectroscopy. And at this small organic fragment present at this fissure at cycle blade, we determine carbon, oxygen, sodium, magnesium, silica. This organic matter preserved at this fissure is secondary mineralized with silica, silica and calcium. Probably primary it was only carbon and oxygen, but after 1,000 years and still mineralization at sands of Qasr el Sagha, into these fissures migrated various substances, mineralizing this primary organic substance. and arrowhead sample number 7, and near of the surface edge, working edge of this implement. There's flint, and there is this edge. At this fissure we have this type of organic substance. This is the crake enlarged 25,000 times, and there is organic tissue, difficult for more precisely done identification, but it's evidently tissue. This implement is arrowhead. So at cracks present under the working edge, we have traces of meat. It's difficult to say, but we did chemical analysis of this substance. You see 5 micrometers. This means this scale is 0.005 millimeter. So 10, 100, 1,000 of millimeter. 5,000 of millimeter is size of the scale. So this is half of this. This is 2.5 micrometers. But structure of this substance suggests that most probably it's not only organic, but this kind of tissue. I think they didn't catch grasses or other things. It's animal tissue after hunting, most probably. And this is chemistry. And of course this tissue is secondary mineralized with silica, aluminium, and other trace elements. Iron oxides most probably. Next, arrowhead sample number 8. And there on the edge, working edge of this arrowhead, after when we did imagination, we enlarged 25,000 times. At this fissure, one can observe traces of organic substance, tissue. Difficult to say what is this, but we did chemical analysis again, and of course this so-called tissue is secondary mineralized with silica, aluminium. There are traces of iron, 4%, and other, not in big amount. But presence of sulfur documents additional that is organic substance. Difficult for more precisely done identification. And working edge of axe sample number 12. This is a system of secondary fissures present just under working edge of axe. This edge was retouched, of course, and later worked, and there are secondary fissures present at flint, just under working edge of the axe. And after examination using scanning microscopy, when this imagination is 25,000 years, not years, times, sorry. Not easy to say all these things in English, especially if you are foreigner. And there is the crake at this place enlarged, and there were done examination at point number 1, where is this red cross, this fissure enlarged. You see there are traces of some substances. The flint look like other. is light and surface is smooth, and so there are some things in these fissures. It was difficult to make precisely done chemical analysis. We obtain only diagram when we have silica, carbon, small traces of chlorium. Something is in this fissure, but difficult for more precisely done identification. Even it's not impossible that we did some examinations and we did some identification of substances, but it was important to show the way of examination. This examination presented at this speech, at my small lecture, show how we may deep go to structure of flints, to edges of working implements, to do more observations and more, let's say, reconstructions of the past. First of all, reconstruction of the force of napping of men according to the size of traces of napping. Next, we may go to the internal structure of the flints just after working edge, where was done retouch, and later was used implement for work. And at the end, using wonderful scanning microscopy together with chemical analysis, we may find traces, very small traces of various tissues, let's say tissues, fragments of matter which was working on these implements were used for work on meat, on wood, on other things. We may see these traces. We may try identify this. What is this? And generally, we may. It's helpful for the reconstruction of the past. But it's necessary to remember that at Qasr el Sagha, where these flints were collected, now we have native desert. There are no woods, there are no animals practically, but at time of Fayumian AB as well as proto-dynastic time, on the banks of Lake Fayum Lake, there was a lot of various trees, animals, etc., etc. So I like to show you this way of work, way of scientific reconstruction. Maybe it will be useful for your work in science. Thank you very much for listening, and I invite you for next my small lecture. My dog is finished. Thank you very much, and see you, inshallah, how they say in Egypt. Mas salama.